What we're standing in right now could be construed as the cathedrals of labor. Take a look around you in this building. What does it invoke? It invokes majesty, it invokes wonder, and it evokes just a tremendous sense of history. These buildings started being built in 1869, finished towards the end of the century, and represented the tremendous amount of work done by both the Central Pacific and Southern Pacific Railroads in the maintenance and construction of railroad rolling equipment, locomotives and cars. So what this represents to us is that history, that ability to tell those stories, the ability to talk about the innovation and invention done by the employees, engineers and designers that worked in this building. Lots of individual innovations came out of here that helped the Southern Pacific become the dominant railroad that it was in the western United States, and now the Union Pacific, which of course has become the owner of the Southern Pacific and all of its work. What these buildings represent is also the future ability to tell the stories of the innovation and construction and ability that was done in these buildings over time for current and future generations to understand that history, and also to be able to participate in future innovations that can be used and talked about in this building, building on the past work that was done. So our hope is to have a laboratory of learning, or the ability to bring students in here and say, let's solve a problem. The kind of problems that were solved in these buildings for over 100 years are the kind of activities and problems we're going to solve here. Aspects of STEM, what's the basic science, what kind of technology are we going to engage, how do we engineer our solutions? That's what we're going to do in these buildings here. We want to start in this corner because this is the oldest part of the shop that dates back to the 1860s. This is the 1869 machine shop. So how do you make machine tools work in 1869? There's no electric motors. Steam. We're running a steam-powered belt.
I got one right.
You got one right. A+ for you. We'll get you to the front of the class. That's it. So they have a long shaft powered by a steam engine that's working. That shaft would then have belts attached to it coming down and driving the equipment. I mean, just take a look around. You look at the construction style, look at the beams. You can still see, look real close, you can see the remains of the brackets that would hold a rotating shaft coming around. But like any other business and any other industrial endeavor, it was constantly being updated and improved and expanded. As we walk down the brick wall here, you'll see obviously changes in elevation as it was expanding to the south. During World War II, there were 7,000 people working here. Also, the story we tell in the Railroad Museum is about a group of female employees by the name of railroadettes. The railroadettes did a lot of the work in the shops and out in the field, because the Southern Pacific, I think, had 12,000 men in the armed forces. So you got to replace those 12,000 guys, and the wartime effort by the railroads was phenomenal. They just were working left and right all the time to supply the needs of the military. And so women did this tremendous amount of work. I think about 7,000 of them worked for the Southern Pacific. See this yellow car right here? This is an extremely innovative piece of hardware built by the Union Pacific. It's known as an engineering car. And what it had in it was the sensing equipment that can inspect the track. Talked about maintenance away, talked a little bit about maintenance. How do you make sure your track is safe so you can run passenger trains at 90 miles an hour and not have accidents? Well, you got to inspect the track on a routine basis. So this little yellow car here had a bunch of guys in it, and they would travel down the track, and they would be looking for just anything they could find that they might think would be dangerous, along with sensing mechanisms. Over time, they developed these non-contact sensing mechanisms, ultrasonics, and other things that allowed you to detect problems in the track before they happen. One of the things that we do in California State Parks is that we collect equipment to help tell the story and the innovation that went into the development of whatever it is we're talking about. When we talk about diesel electric locomotives, you're looking at one of the first ever built that was a, let's say, production model that you can actually call somebody up and look at a catalog of sorts and say, I want one like this. Now, you should be looking at that and you might be thinking streetcar. This is sort of a modified streetcar that had its own little Ingersoll Rand diesel engine in it, along with General Electric generators. Now that you're making your own electricity, you take that electricity and you put it down into the wheels, the traction wheels, that are already existent on streetcars. So this is sort of like a streetcar, except you don't have the overhead catenaries. It's making its own electricity, and of course it's got then cars behind it that's pulling the train or the consist. So we like this piece of hardware. We have it on exhibit every once in a while because this represents really the beginnings of the diesel-electric locomotive manufacturing that was routine enough that it was a standard production model. Now, if you take a look over here, you see the locomotive that says Holly Sugar. That is the very first diesel-electric locomotive owned by the Southern Pacific Railroad. That was Southern Pacific number 1000. So it is very, very, very historic. Let's say you got two railroads coming together, or you got two of your tracks coming together, and so you got the way of going 4 different directions, and you got a crossing you got to make happen, and you don't want to have any collisions, and you want to make sure you get the train going in the right direction, and it's 1910. So you're going to put people next to every switch, have them throw the switch when somebody comes in and says, I got to go here, or you're going to have some piece of hardware that makes it happen. The answer is smart people innovate and invent, and they come up with ways to do this, and that's what's underneath the tarp here. So I'm going to take these off and just show you something that is really, really neat. This is known as an interlocking machine. And every one of these switches, every one of these levers goes to a switch that makes either a switch move. Now by switch I mean it's the track. So if I've got my train and I'm leaving Sacramento and I want to go to Stockton, but I don't want to go to Roseville, I got to throw a switch. Now you can stop the train, you take a brakeman out, throws the switch, away you go. Or you just say, I'm going to sit in a tower and I'm going to operate the levers, and wham, the switch will move. Train goes through, you go, okay. Switch goes back to where it needs to be. So you got somebody standing in a building that's about 3 stories high, watching everything. They have a timetable. The thing to remember about the railroads is it operated with exquisite perfection using printed instructions, so that you knew at 9:10 in the morning, you got this train leaving Sacramento and it's on its way to Stockton, so you get ready to throw that switch. You see it coming. This also turns on lights in the right place. This is a digital computer before electronics were invented. So again, that's sort of the innovation, and the story we can tell here is this constant stepwise improvement that created a very efficient transportation system. This is the engine that was in one of the very first diesel-electric passenger locomotives. So it became available to us, and so we're happy to have it, because again, it represents this flow of innovation, this flow of development that takes place. Again, keep looking at the building. We expand, we get different, it gets bigger, looks different. You can kind of see the flow of the expansion. 1869, 1879, we're working our way south. Over here to the left is the expansion so we can deal with longer locomotives. Think about the size of the cab forward, which is the one we have in the museum. 6819 is the tunnel motor, very innovative in the way it provided extra cooling for the radiator. That may not seem like a very big deal, but when you're going through a mile-long tunnel at maybe not necessarily high speed, you fill that tunnel up with hot air and you're not necessarily doing the cooling you need, and you certainly got a combustion problem because you're using up all the oxygen as well. We even have our own redwood log, probably 1,500 years old. And that helps us talk about how did the railroads support the logging industry. So if you got a redwood log this size, do you try to pick it up and put it on a flat car? Or do you take the trucks, that's the wheels, and strap it to the redwood log? That's what you do. You take the trucks, you put them there, and you just strap them onto the log, and you move down wherever your little railroad goes to the sawmill, and then you put the cut lumber on flat cars and send it on in. How do you run a railroad when you got 40-foot snow drifts? I want to get over Donner Pass in the middle of the winter. How do I do that? Well, you got to have a way to get the snow out. So over time, the industry, and somewhat perfected by the Southern Pacific, they developed individual pieces of hardware to get the snow off the track. This is like a giant scoop or a snow shovel right here. and it's got notches in it. This device then would drop down between the rails and it would scoop the ice out, shove it over. And so now you had no ice between the rails, and so you could a little bit more safely operate your train. So we have all kinds of examples of how the railroad solved problems. I keep stressing that because what we're talking about here is innovation, invention, solving problems. Some may seem mundane, but they solve a lot of problems. All right, end of my stories. Questions, comments?
This whole place is so amazing. It's huge. And the whole operation that's going on in this environment is just very exceptional. It's an excellent opportunity for young people K through 12 to visit this laboratory of learning and be a part of the future, because what we learn from the past enables us to adjust and be ready for our future.
This is my first time at the rail yards. I've been to the museum, of course, but it was very exciting to see the rail yards. So I teach at a community college, and right now, you know, when I think of technology, it's all about AI. It's all very much screen-based, and the rail yards represent a technology in the past and the innovation that Sacramentans and people all over the world had to develop the technology in their day. And my mind as an educator is whirring with the idea of bringing students here to the rail yards to consider their futures while also appreciating the history of their community and all the innovations that have happened here in Sacramento. I think that's inspiring.
The best of what we do is we help young people, and all people really, imagine their futures through understanding their past. So when we think about the future of this place, it's not merely just let's walk in and look at collections, or let's walk in and look at people working. But we increasingly think about kind of three things, and one of those is certainly the visitor interface, that kind of extension of the campus. The other is how can this be a place of community, and then the third thing really is that laboratory of learning. And I think when you put all those together, this becomes a really important part of the museum's future and part of Sacramento's future.
I'm Stephanie Taylor. We're standing in front of the mural I created originally in 1999 for the Rail Fair. And I repainted it in 2017 for Wide Open Walls, and it's a wonderful project. I haven't been in to the shops for a very long time, and I was so surprised to see that all the trains are in such great shape, and it's still a working shop. It brings history alive for students to go in there and maybe not climb on the machines, but see them and smell the old oil and look up close at the history. It will bring it so much more alive. And it's all about technology and innovating over and over and over.